here. So I'm going to go to factory 2 and select this data point. Instead of being 33, I'm just going to change it just a little bit. I'm going to change it up to 35. Okay? And for the purpose of this video, let's suppose that the null hypothesis was that the means are the same as we had before. But for the research hypothesis, let's say that the mean for factory 1 is greater than the factory 2 mean. Let's suppose that we had reason to believe that those two means might in fact be different in this sort of way, where factory 1 is greater than factory 2. I have the statistics from the first test that we ran here, and I'm going to rerun the test with the error in factory 2, and I'm going to highlight this value right here to just show the color here. Okay, so that's the value that we've changed. We've only changed one value. I'm going to run this test again. It's going to be the same test. I'm just going to store the results a little bit in a slightly different location so that we can compare our results. Remember, now we're doing a one-tail test because we have previous reason to believe maybe factory 1 puts more M&Ms in their bags on average than factory 2. So I'm waiting for my tool pack to upload here for Google Sheets. While it's doing that, again, just to review a couple of things. In this case, we didn't have the same number of data values, and that's okay because these data are coming from two different locations, and they're not paired, they're not matched up, as we'll see in the material for chapter 12. So now that this is uploaded, I can access again my t-test for 2 samples assuming unequal variances. My variable 1 range is the data for factory 1. Again, I'm including the label. And then my data for factory 2 is right here. Make sure that I click in here. And my hypothesized mean difference. So the null hypothesis is that they are the same. So the difference between the two we're hypothesizing is 0. I am including the labels. My alpha is staying the same at 0.05 for this. And now for the output range so that we can do this comparison here. I just kind of move over a little bit. I'm going to put the output here, and I'm going to run my test. Okay. Now we have our next set of results. Now remember, we used a one-tail hypothesis. Okay. So in this case, we went from a one-tail of 0.0263 to a one-tail of 0.039, which would mean that we would reject the null hypothesis, but there is still an error in our computation. This is not the correct p-value because we used the wrong data. And what I'm going to do is I'm going to adjust the data even more. I'm going to go back to my data. And now let's say instead of 35, let's say that this one I typed in as 38. And again, this is another error. I'm going to run the same test and put it in the same output location. And we'll go take a look at the results. So now with those two data values, now our one-tail t-test, we would actually fail to reject the null hypothesis just because of a typo with our data. So just by changing those two numbers, we were we created enough of an error that we would actually fail to reject the null hypothesis when there was actually enough reason from our data to reject the null hypothesis. So again, this is just a reminder of how important it is to make sure that we're being very careful with the data when we're entering it. Make sure that we're actually running the tests on the correct data. If I run this again with the correct values, we will once again reject the null hypothesis. Again, 0.0263 is less than the 0.05, so we would say that our p-value is less than our critical value, and since it's less than our critical value, we would reject the null hypothesis in our one-tailed test.